Hello everyone. So in this video I am going to talk about flame photometry. So we will discuss about the flame photometry introductory parts. Then I will discuss about what informations we are getting from flame photometry. So let us start learning of flame photometry. Flame photometry, a branch of atomic spectroscopy, is used for determining the concentration of certain metal ions such as sodium, potassium, lithium, calcium, cesium. The basis of flame photometric working is that the types of metals are dissociated due to the thermal energy provided by the flame source. Due to this thermal excitation, some of the atoms are excited to a higher energy level where they are not stable. The subsequent loss of energy will result in the movement of excited atoms to the low energy ground state with emission of some radiation as a wavelength. The emitted wavelengths are specific for specific elements. Look at this pictorial picture. Brief overview of the process. Ions in solution. Here, aspirations, aerosol, vaporization in flame, molecules, thermal dissociation in flame, ground state atoms, heat energy absorbed, excited state, energy emitted in the form of light, return to ground states. Now, the solution containing metal to be measured is first aspirated into the bonder. The second, the solvent then evaporated, leaving fine divided solid particles. The solid particles move towards the flame, where the gaseous atoms and ions are produced. The ions absorb the energy from the flame and excited to high energy levels. When the atoms return to the ground state, of radiations of a characteristic element is emitted. The intensity of emitted light is related to the concentration of elements. Now, name of elements: potassium, lithium, calcium, sodium, and barium. Emitted wavelength range 760 670, 622, 589, 554. Observed color of the flame: violet, red, orange, yellow, and lime green. FV for flame photometry components. Flame, a burner that provides flame and can be maintained in a constant form and at a constant temperature. Nebulizer and mixing chamber. It helps to transport the homogeneous solution of the substance into the flame at a steady rate. Monochromator helps in isolating the wavelength to be measured from that of any other extraneous emission. Now, photodetector. It detects the emitted light and measures the intensity of radiation emitted by the flame. That is, the emitted radiation is converted into an electrical signal with the help of photodetector. The produced electrical signal are directly proportional to the intensity of light. Now look at the pictorial picture. Flame, lens, filter, photodetector, amplifier, readout, burner, waste, U-tube, train, air inlet, nebulizer, gas inlet, mixing chamber. This is the pictorial picture of the flame photometer. Now, burner. Burner used in FP, means flame photometer, should have the following properties. The flame should have ability to evaporate the solvent to give a residue deposit. It should convert this residue to gaseous state, atom, and finally into individual atoms. My friend, the effect of flame depends on the temperature of flame, and this temperature can be monitored by following method. Fuel to air ratio, types of solvent for preparing sample solution, amount of solvent which is entering to flame, type of burner used in flame photometer. Now what is flame? Flame photometry employs a variety of fuels, mainly air, oxygen or nitrogen oxide as a oxidant. Burner are of two types, total consumptions burner and premix or laminar flow burner. Now various processes in the flame are discussed here. Dissolution, the liquid solvent is evaporated and the metal particles are dehydrated by the flame. Vaporization, the sample vaporizes to a gas. Atomization, reductions of metal ion in the solvent to metal atom by the flame heat. Now excitation. What is excitation? The electrostatic force of attraction between the electrons and the nucleus of the atom help them to absorb a particular amount of energy. The atoms then jump to the excited energy state. Emission process. What is emission process? Since the higher energy state is unstable, the atoms jump back to the stable low energy state with the emission of energy in the form of radiation of characteristic wavelength, which is measured by the photodetector. Now types of flame photometer. Directive, a standard solution of sodium and potassium are atomized or spirated into flame to provide a series of meter reading in which our unknown is going to be compared with. Next, direct type disadvantage. Any minor fluctuation in air, gas pressure might change response of the instruments and then cause errors. Separate analysis and sometimes separate solution must be made for sodium and potassium. Now internal standard method. Another elements, lithium is added to all standards, blanks and unknowns in equal concentration. This element has a criteria of high emission intensity, is absent from biological fluids. Now application. Determine the availability of alkali and alkaline earth metals which are critical for soil cultivation. In agriculture, the fertilizer requirement of the soil is analyzed by the flame test analysis of the soil. In clinical field, sodium plus and potassium plus ion in body fluids, muscles and heart can be determined by diluting the blood serum and aspirations into the flame. Analysis of the soft drink, fruit juices and alcoholic beverages can also be analyzed by using flame photometer. What is the advantage of this technique? Simple quantitative analytical test based on the flame analysis. It is inexpensive. The determination of the elements such as alkali and alkaline earth metals is performed easily with the most reliable and convenient method, quick, convenient and selective, and quiet, and sensitive to even parts per billion ppm to parts per billion range. Friend, flame photometers suffer the same level of interference as AAS form, anion due to complexations matrix influence, Borner interference, ionization interference, and emission influence. What is the limitation of this technique? Alterations of light emission because of altered flame temperature. It needs perfect control of flame mid-temperature. Interference by other elements is not easy to be eliminated. Heavy and transitions metals, the number of absorptions and emission lines is enormous and spectra are complex. Adequate selectivity of real differences in viscosity between the standards and simple. Advantage of AAS over FP: sensitivity, applicability, smaller flame effects, less influence from other cations. The differences here you can see in AAS: atomic absorptions and flame photometry. Process measure absorption, light absorbed by unexcited atom in flames. Emission, light emitted by excited atoms in a flame. Use of flame, atomization and excitation. Instrument, light source, no light source, independence of flame. Beer's law, applicable, not applicable. And data obtained, absorption versus C and intensity versus concentration. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.